Welcome to this session by PCTEL. We're glad to be joining this event with SBC and Tessco. And we actually have two parts of our presentation today. First, I will start with a session that's focused on trends in the marketplace as it relates to in-building radio systems to support public safety. And then we'll have a section at the end after mine with George Alagi on related to antennas and infrastructure. So I hope you guys found it valuable. So the first trend that I'm going to talk about is the fact that there's a really growing, expanding understanding of what networks and what technologies are involved with assuring that buildings are safe from a communications point of view. So historically, certainly for the last 20, 25 years, there's been a growing emphasis on making sure that the radio systems that are used by the local fire and police departments, EMS, work well enough inside a building so they can safely do their job and help people, particularly in emergency situations. Now, they're there in buildings a lot for non-emergency, and it's important then, but certainly it's much more critical when you're fighting a fire, responding to criminal activity or something like that, that these guys need to be able to talk to each other. And so really, for the longest time, there have been a focus on talking about this, adding it to fire and fire codes and building codes to actually kind of enforce the fact that the first responders can use their voice communication networks inside, basically to answer the question, are first responders safe and can they safely help people? So what this involves, of course, is that jurisdictions, authorities having jurisdiction, AHJs is a term we'll use, have their own networks typically deployed. Now, sometimes these are shared between cities and counties or multiple counties or even statewide systems, but some version of a network that's owned and operated by a government agency. It started with analog, it evolved to some digital technologies like P25. There's other ones like EDAX, NXDN, Tetris used a lot over in Europe. But these networks are owned and operated by the AHJs. And what they want to do is to ensure that the buildings work well, the communication works well inside. They write into codes, fire codes and building codes, and they say, you must measure, you must test, you must validate that certain performance is available. And if not, you fix it and test again at the end and provide documentation that this works. So this has been the big focus, really picked up emphasis after the tragedy on 9 in September 2001. But over time, that's evolved in such a way that the codes, NFPA has a code called 72, which has a section 1221 that talks about radio performance. The International Fire Code, IFC, has a section 510 that talks about this, and states will adopt it, jurisdictions will adopt it, some version of it, maybe modified a little, but all of them have this common theme to make sure these networks work well in building. But what's happened over time is as we start to talk about, is this building safe to work in, to live in, you start to think about more than just emergency situations, but you ask the question, can the occupants, the people who live there or work there, can they make 911 calls if they need to? Can they get notifications about emergency situations? And so now you start to think about these cellular networks. Typically, you're talking about 4G LTE, eventually 5G is going to be in these buildings. And you say, do those work well enough? Beyond occupants being able to do emergency communications, you also find that the first responders, the fire and the police, are going to want to start using those technologies. Typically, it's going to be provided by FirstNet or by one of the other operators. But these networks are a little different. They're not owned and operated by the jurisdiction, but they're commercial or a special public safety version like FirstNet provides. But again, now you're asking, can cellular networks work well in a building for emergency purposes, safety purposes? And lastly, there are definitely certain businesses that have what we would call a private network that's dedicated for their own usage when it comes to safety and security. So if you might think about hospital campuses, university campuses, oil fields, data centers, warehouses, lots of places actually have their own security teams. They will often be the first people that respond. I've heard the term first responders. And so they actually think of this as more critical than even the public safety network owned by the jurisdiction, because their people will be on site responding first. A lot of times these are other digital technologies like DMR or Tetra P25. Some people are starting to use private LTE. But again, these are networks, have a third characteristic. They're owned and operated by the building owner, the property manager, the business itself. And so really for them, for their buildings to be considered safe, they're going to think about all three of these as things go on. Now, when it comes back to what is being enforced today by jurisdictions, it really is restricted to that first one. That's what's in building codes and fire codes. But over time, we'll start to see more of those FirstNet and other cellular technologies being required as well. So that's a big trend. That's the way things are going throughout the industry. Secondly, is there's a growing, ever evolving kind of approach to how these systems and their capabilities are managed. We talked about the two codes, NFPA and IFC. What is happening is more and more places are adopting it. Not every jurisdiction, not every AHJ actually has a building or fire code that mandates good radio coverage. You'll actually see states. Florida's had one in place for a while. California just announced that they have now a statewide mandate that's pushed down to the local cities and counties. But it's definitely evolving over time, over the last few years, over the next few years, more and more pieces adopting. The other big thing that had to accompany this is not just the codes adopted and enforced, but you needed the knowledge of what to put in those codes and how to enforce them. And so certainly we see more and more educational opportunities, more and more jurisdictions investing time and effort into learning. And so that's a great trend to watch, is to see more and more people understanding how these radio systems work and what needs to be done. One of the biggest factors is there's, besides the people who manage the codes, there are the people who manage those networks. They would be radio shops, something like that. These people typically are the ones who hold the license from the FCC. So when the networks are put out and they have certain frequencies they use, those frequencies are granted a license to them by the FCC. And so in theory, every time you put an in-building system in and want to make it work and turn it on, you must have their permission. They have to review your work, your submittals, and grant you the authority to turn your in-building system on, because you're using licenses that they hold, a frequency they hold licenses for. And so what we see about all this is more and more cooperation between the code officials in the AHJ and the radio shops who are the license holders. And that's great to see. The more they work together, the better their jurisdiction is going to be able to make sure these buildings work well from a radio point of view. We also see growth or change or evolving when it comes to what is tested to make sure the network works. Historically, it's always been downlink power, but over time, people realized you could have a good power level and voice communications still could be corrupted. And so let's do a live voice test using DAQ scoring. And then, of course, as the RF engineers began to influence this, they said, listen, there's a better way to test than just voice. Let's use signal to noise ratio. Let's use a bit error rate. And oh, by the way, let's not just test the downlink, but let's test the uplink. So all of these things are working their way into code. as the code evolves, it's working their way into local focus on adopting it and enforcing it. And if you really want to make sure these systems work well and they don't interfere with the outside network, there's lots of tests that have been added over time. Let's do what's called a near far test so that radios that are near to antennas don't drown out radios that are far from antennas. Let's make sure that the inside and outside networks are isolated. Let's make sure the inside's not leaking out. Let's make sure all the antennas are working. So more and more education, more knowledge, better test practices. Um, and that also drives down to who's doing the testing, who's doing the design, who's doing the deployment, who's doing the testing. Let's make sure you're certified. Programs like NICET are starting to be developed. Some people are starting to think about, let's have independent third-party testers. So you make sure people check each other, that their work is good. So all these types of things are really trends that are going on in the market as the way these buildings systems are managed. And lastly, and I'll kind of go through this quickly, is that there's a lot of different companies starting to get involved. Companies that historically did public safety are now starting to add cellular so they can do those FirstNet tests or other just commercial service. People that have done commercial cellular DAS are starting to get into public safety. And both of those are situations where if you're in a building doing work, you might as well do as much for the building owner as you can. There's a lot of companies that have historically been fire companies from an alarm, sprinkler, low voltage point of view that are starting to get involved in saying, we can offer you the service of at least testing your building. And if you need a system, we can partner with someone to put it in. The requirement for certifications is definitely growing, and pay attention to the NICET announcements that you'll see next year about certification for people who do this kind of work. And so there are certainly partners, companies that are, expertise in design that are helping some of these newer companies like fire companies. Equipment vendors are very active, some more than others, in providing training along with equipment that they provide. And of course, near and dear to the heart of PCTEL is our test tool improvement. As we've watched all of these trends, we've made sure to try to keep up with the kinds of test requirements that come out of all these trends. Testing multiple bands and technologies at a time is one example. Reducing the amount of time so it's very efficient. Making it easy and ergonomic to do. So you have to push carts around and people don't have to go see chiropractors when they get done carrying test equipment. And doing more accurate and high performance measurements like signal to noise and BER. We have been making test equipment for measuring radio network performance for over 25 years. And in the last 4 or 5 years, we've really focused on the public safety radio systems in particular. So we now produce kits that have a complete test solution for testing public safety, cellular, and other types of business critical radio networks, both in building and outdoors, with a particular focus on the grid test requirements that show up in the building codes and fire codes in the US. So again, thanks for letting us talk about the trends for testing. And next, I'm going to turn it over to George Alagi, who will talk a little bit about antennas.
All right, so great presentation there, David. And hello, everyone. My name is George, and I am the Senior Director of Product Management for PCTEL's antenna and devices product lines, product groupings. And today I want to take the remaining time of the presentation, or this second section here, to talk to everybody about evolving requirements for antennas in the public safety market and public safety space. And what are the different things that are required to make communications safer and more reliable? Everything that David talked about, I want to kind of expound on that a little bit, strictly from an antenna perspective. So first, we'll talk about the expanding networking technologies for public safety. A lot of the, this is work that's been going on for many years. but the requirements for antennas and advancement in antennas is really driven by the evolving technology and capabilities of the wireless networks that these antennas support. There are continuous upgrades in various networks that the public safety agencies use today, or the networks that they're thinking about transitioning, even the legacy two-way and voice networks that we've been providing mobile whip and mobile antennas to for many, many years. Even those have advanced with combined frequency channels, wider frequency bands, combined networks. Radios that previously had ports dedicated only for a specific band or frequency range now have ports that combine VHF, UHF, and all the 700, 800, 900 megahertz bands. And accordingly, to avoid the use of complex diplexers or triplexers in installations, it's important to have broadband antenna technology that can cover all these multiple frequency bands in a single port. This can be demonstrated with certain antennas like our wide spectrum mobile whip series of antennas. Similarly, with the cellular networks and the publicly operated cellular networks, the frequency ranges are always being extended to accommodate new spectrum and new corresponding additional channels. The antenna side of the house, we always speak in frequency ranges and spectrum rather than channels or bands. So that's there's always that correlation of trying to coordinate between the evolving technologies. But we saw this before. We saw this before with the addition of the 700 megahertz 4G LTE channels and the FirstNet bands, which led for multiband antenna requirements to have to be upgraded from what we used to refer to as 3G to 4G antennas. And those antennas, would cover, initially the 3G antennas would cover 806 to 960 and then up to let's say 2100 megahertz. Then as we expanded to 4G, the frequency range is expanded to cover anywhere from 690 through 2700 megahertz, or maybe up to 3800 megahertz. And now we're seeing with the upgrade to 5G, the antennas now have to support 600 meg to 6000 megahertz or 6 gigahertz. And so that's, sort of the next major evolution when it comes to cellular and antennas that support those broadband cellular bands that David had talked about earlier. And of course, not to be outdone, the leading technology for the broadest sub 6 gigahertz band antennas, Wi-Fi, is adding yet another gigahertz of spectrum for Wi-Fi 6 extended bands. This will require that the antennas today that are dual band 2, 4, and 5 gigahertz Wi-Fi that typically cover up to 5.9 or 6 gigahertz. Now those antennas will need to be expanded to cover frequency ranges up to 7.125 gigahertz. So with that, the need for more capable antenna hardware does not end with just the evolution of the wireless networking technology. The next set of enhancements involves combining all the different networks into a single combination antenna. It might be a combination antenna platform, like some of the antennas that you see here pictured on the slide, or it may be an antenna system that is on the top of a vehicle. And these systems need to have the ability to communicate via multiple networks simultaneously without interference and without the loss of any performance. In public safety, we've discussed topics like interoperability and redundancy for years, or for decades even, and using various networks available at the same time makes public safety communications safer and more reliable. And this first example here of an antenna system shows the antenna system that's on top of the #1 selling police fleet vehicle in the US. And this antenna system has antennas for VHF communication, UHF communication, multiband antennas that cover both cellular operators and Wi-Fi networks, along with GNSS coverage for location and timing, and then legacy systems for broadband data that are connected. And all of these systems need to be able to operate together seamlessly. And the second images here, these multiband antenna platforms that you see on the right side of the screen, these are systems that have other enhancements that have the capability for dual carrier or dual operator function with 4 individually optimized cellular elements that are optimized for uplink and downlink performance, and can be used for different use cases in public safety communications. And it could just simply be used for redundancy, where you would flip from one operator to the next operator, or it can be used for aggregating bandwidth from the different operators for a higher throughput performance in these applications. And these fixed antennas they're also ideal for outdoor DAS applications. So, with that, PCTEL has, several different platforms for doing public safety communications, whether it's some type of a fixed infrastructure platform, or very popular mobile platforms that can be seen on many police, fleet, and first responder vehicles, or in-building antennas. The one thing that sets PCTEL apart, aside from the advanced electrical and mechanical designs, is the ability to use PCTEL's performance test and measurement solutions for live network testing. That's something that we're able to do, being able to use PCTEL's IV Flex and some of the equipment that David talked about in the first session. We're able to put our antennas on a live network and test the performance, test the KPIs of the network, test how they're doing with the changes and advancements that we make with technology. And that's a true differentiator when it comes to using PCTEL antennas for public safety communications. And that's about all I had. Yeah, so thank you for your time today, everybody. We hope that you found this very informative and useful, learning about PCTEL's test and measurement solutions and how we use those solutions to advance our antenna technologies, and how we're advancing technologies for more safer and more reliable public safety communications. Thank you again.